Okay, we're on the seventh problem. It's a surface area problem again, and we have this here, and we're going to rotate about the x-axis. You know, the pictures are nice, but I'm going to say it's not totally essential. What about this? We got from 8 to 27. So if I were doing the problem, you know, after doing 6 questions, I know what my integrations are going to look like. What do they look like? Well, I'm going to along the axis, I'll say from 8 to 27. Then I get to 2 pi, and the r in this case is going to be the y value. And what's the y value? It's 9 minus x to the 2/3 to the 3/2 times, there's going to be a root over here and a dx over here. Now my trouble is this root thing, and I got to do that now. And the root thing is going to be 1 plus dy dx quantity squared. I got to figure that out, by the way. Again, this might look awful to you, but I can assure you these problems are written to work beautifully. So let's write the dy dx down. And what do you get there? Let's take a look. You get 3 over 2, and then you get 9 minus x to the 2/3, and I got to reduce the 3/2 by 1, which would be 1/2. And then I got to do it with the inside. Wow, what's it going to be? Minus 2/3. And then what do you get? X to the minus 1/3. I got to square that. Before I do that, though, I want to simplify it a little tiny bit. And I'm noticing over here that the numbers work out pretty nice, by the way. It's just simply negative. Right, the 3's cancel, the 2 cancels. And then I get this 9 minus x to the 2/3 to the 1/2 power. And on bottom I get x to the 1/3. And I got to square that. Right, so when you square that, what do you get? You get dy dx. I'm going to square that. And you would get 9 minus x to the 2/3. And on bottom, you get x to the 2/3. All right? So what I'm going to do is I'm going to add 1 to that now. All right? So 1 plus the dy dx squared is equal to, well, that looks pretty convenient, doesn't it? If you add 1 to that, it's like x to 2/3 over x to 2/3. You would get x to the 2/3 and then 9. And that worked out pretty nicely, by the way. So I'm going to go back up here and write that down for you. So it's going to be 9. And then you get x to the 2/3 here. All right, I'm kind of running out of room. I'm going to erase my scratch work on the side. And I need to plow forward. All right, plowing forward is always difficult. But I do have this first milestone met. Before I do anything, though, I want to point out, I want to see if I've got the milestone down. 8, 27, 2 pi. I got this, and I see this. It wrote a little differently, but I do see it. I'm going to simplify it, and simplification some can be very difficult, but I'm hoping this thing works out pretty nicely for me. And what do you over there? Let's take a look. I'm going to do the number first. The square root of 9 is 3, and 3 times 2 times pi is 6 pi. You get 8, 27. I'm seeing the 9 minus x to the 2/3, that's to the 3/2 power. And when you take the square root of that, you know, x to the 2/3, you get, you know, 1 over x to the 1/3, which is x to the minus 1/3 dx. And next thing I would do is probably use a u substitution. So I don't see much else to do. I'm going to say u equals 9 minus x to the 2/3 du would be minus 2/3 x. You're going to decrease the exponent 2/3 by 1, so minus 1/3 dx. I'm starting to see it now. Let's keep going. Equals 6 pi. I'm going to do the lower limit first, which is 8. And 8 to the 2/3 is going to be, well, the cube root of 8 is 2, and 2 squared is 4, and 9 minus 4 is 5. Let's do the upper limit. The upper limit is, 27, so 27, the cube of 27 is 3. 3 squared is 9, right? And, 9. 9 minus 9 is 0. All right, let's keep going. And I see u to the 3 halves. All right, let me point out what I've done so far. I got the limits done. I've got this done. And now I'm looking at this thing over here, and I do see it. And what's it going to be equal to? It's actually equal to minus 3 over 2. Now I'm going to put that on the outside. I'll erase this over here. And then you're going to get du. All right? I'm starting to see something here. It might make it a little bit easier for me. 2 goes into 6 3 times, and that would give you minus 9. And I'm just going to reverse the limits of integration now and call it 9 pi. And I'm going to go from 0 to 5 now. U to the 3 halves. Du. Let me do my integration. 9 pi. This would be u. Increase it by 1. That would be 5 halves. And what do you get there? The limits of integration. I'm sorry, I forgot to do this. Divide by 5 halves, which same thing is multiplied by 2/5. Integration 0 to 5. Let's keep moving. And what do you get there? It looks like 18 pi over 5. 5 halves is 2.5, which means 5 squared, which is 25. And then you'd have a root of 5. The limit of 0 is easy, though. It's just simply minus 0. So I think I'm ready to write the answer down now. And what do you get? 5 goes into 5 once, goes into 25 5 times. 5 times 18 is 50 and 40, which is 90. So it'd be 90 pi root 5. Let's look at the key, see how we did. I'm looking for the 90 pi root 5, and I do see it right over here. I want to point out work is written down for you for a reason. If you're struggling, look at the work before you look at the videos. However, sometimes looking at work doesn't help, so go to the video then. Look at the videos which we're presenting to you. Thank you for paying attention.